Alright, let's take a look at this question. We are still talking about how to obtain critical number and critical points of a curve. Okay, now let's take a look at this question. Find a critical number and the corresponding critical point for the following curves. 1. S squared cubic root of 2x minus 5. Then number 2, x plus 5 in bracket raised to power 2 cubic root of x minus 4. Alright, okay, let's take a look at this. We are asked to find the critical number and the corresponding critical point for this course. Okay, now let's go. The first step, we have to differentiate, we have to differentiate the function given to us. Alright, okay, but before we differentiate, I want us to do something here. We have a function f of x is equal to x squared cubic root of 2x minus 5. Alright, yes, now this cubic root of 2x minus 5 can be written as 2x minus 5 in bracket raised to power 1 all over 3 is the same. Okay, now let's go. Here now we are having x squared open bracket 2x minus 5 close the bracket raised to power 1 all over 3 as our function. Alright, okay, now we are going to find the derivative of this function. We are going to differentiate. Okay, so that means we're going to have f prime of x is equal to 2x open bracket 2x minus 5 close the bracket raised to power 1 all over 2 plus x squared times 1 all over 3 open bracket 2x minus 5 close the bracket raised to power 1 all over 3 minus 1 times 2. You get it? So what we did is we used a product rule on this differentiation. To differentiate it properly, you make use of product rule. Okay, yes. Now let's go. When you use product rule, this is what you're going to obtain. Now let's simplify this properly. So we are going to have 2x open bracket 2x minus 5 close the bracket raised to power 1 all over 3 plus x squared times 1 all over 3 open bracket 2x minus 5 close the bracket raised to power minus 2 all over 3 times 2. Okay, now let's go. We're going to have 2x open bracket 2x minus 5 close the bracket raised to power 1 all over 3 plus 2x squared times 1 all over 3 times 1 all over 2x minus 5 in bracket raised to power 2 all over 3. This last time we have 2x minus 5 in bracket raised to power minus 2 all over 3. So this minus is going to give us 1 all over. We have 2x minus 5 in bracket 2 in bracket raised to power 2 all over 3. Alright, yes, now let's go. Still simplifying, we're going to multiply 2x squared and 1 all over 3 together with 1 all over 2x minus 5 in bracket raised to power 2 all over 3 all together. Okay, so when we multiply that, we are going to have 2x squared all over 3 open bracket 2x minus 5 close the bracket raised to power 2 all over 3. Alright, and then in the other side we have 2x open bracket 2x minus 5 close the bracket raised to power 1 all over 3. Alright, now let's go. Here we are having a fraction. Okay, we can combine this together. If we want to combine this together, I'm going to look for the LCM. What is the LCM? LCM is 3 open bracket 2x minus 5 close the bracket raised to power 2 all over 3. Alright, so when you combine this, we're going to have 6x open bracket 2x minus 5 close the bracket plus 2x squared. Okay, you may ask how or where, how did we get this 6x? We have a numerator, we have a LCM to be 3 open bracket 2x minus 5 close the bracket raised to power 2 all over 3. Now divided by 1 is going to give us the same thing. So multiply by the numerator in the left hand side. You can simply just take the 3 multiply by 2x. It's going to give us the 6x. Okay, now let's go here. Now let's use this 6x to open this bracket. 6x times 2x is going to give us 12x squared. Then 6x times minus 5 is going to give us minus 30x. Then we have plus 2x squared. So here we have 12x squared minus 30x plus 2x squared. Okay, so when we say 12x squared plus 2x squared, it's going to give us 14x squared minus 30x. Now we have all over 3 open bracket 2x minus 5 close the bracket raised to power 2 all over 3. All right, yes. Now in our numerator, let's factor out 2x squared. Let's factor out 2x. So when we factor out 2x in 14x squared, we're going to have 7x remaining. Then when you factor out 2x in 30x, we're going to have 15 remaining. So that when you say 2x multiplied by 7x, you're going to give us 14x squared. And then 2x multiplied by 15 minus 15, you're going to give us minus 30x all over 3 open bracket 2x minus 5 raised to power 2 all over 3. All right, so here we have differentiated. So the next step is to replace x with x naught and equate it to 0. Okay, so here we replace x with x naught. So in our function we have f prime of x naught is equal to 2x naught open bracket 7x naught minus 15 all over 3 open bracket 2x naught minus 5 close the bracket raised to power 2 all over 3 equal to 0. Okay, so here now we know we are having numerator and denominator, right? So we are going to equate our numerator to 0 and then also our denominator equal to 0. In our numerator we're going to have 2x naught open bracket 7x naught minus 15 equal to 0. So here we have 2x naught equal to 0, but we want to make x naught the subject. Okay, we are solving for x naught. So here when we divide both sides by 2, we're going to say that x naught is equal to 0, and then the term in the bracket we have 7x naught minus 15. So 7x naught minus 15 is equal to 0. All right, so we take minus 15 to the other side, so we're going to have 7x naught is equal to 15. So divide both sides by 7, so x naught is equal to 15 divided by 7, or 15 all over 7. So when you say 15 all over 7 in decimal, it's going to give us 2.14. All right, so here we have solved this curve and we obtain two critical numbers, x naught equal to 0 and then x naught equal to 2.14. all right, this is for the numerator. Now for the denominator we have 3 open bracket 2x naught minus 5 in bracket raised to power 2 all over 3. So here now we discover that 3 cannot be equal to 0. all right, yes, it's not equal to 0. Now let's look at the term in the bracket. So we have 2x naught minus 5 equal to what? 0. So 2x naught, we take 5 to the other side, say it's equal to 5. Now we are solving for x naught, so divide both sides by 2. So we're going to say that x naught is equal to 5 all over 2. In the decimal form, we're going to say that x naught is equal to 2.5. all right, yes, finally we solve for the numerator and the denominator. We obtained 3 critical numbers. Number 1, x naught is equal to 0. Number 2, x naught is equal to 2.14. Number 3, x naught is equal to 2.5. all right, yes. Now let's go. Let's solve for their corresponding critical point. Okay, let's pick this point one after the other to solve for its corresponding critical point. All right, now let's go. For x naught equal to 0, in our function f of x is equal to x squared cubic root of 2x minus 5. So here we can fix 0 in this function to see what we're going to obtain. So when we fix 0, we're going to have f of x naught is equal to f of 0 is equal to 0 squared cubic root of 2 open bracket 0 minus 5. So everything is going to give us 0. So therefore, for x not equal to 0, the corresponding critical point is going to give us p of 0 comma 0. You get it? For x not equal to 0, its corresponding critical point is 0. Okay, here we have p of 0 comma 0 as the critical point. Now let's go. For x naught equal to 2.14, let's solve for its corresponding critical point. Now let's go. F of x, you know, is equal to x squared cubic root of 2x minus 5. Now we're going to plug in 2.14 in this function to see what we're going to get. So we're going to have f of x naught is equal to f of 2.14. In this function we have open bracket 2.14 close bracket raised to power 2 cubic root of 2 open bracket 2.14 close bracket minus 5. When we simplify this, we are going to have equal to minus 4.1. So the corresponding critical point is going to give us p open bracket 2.14 comma minus 4.1 as the critical point. All right, now let's go for the last one. We have x naught equal to 2.5. Let's solve for the corresponding critical point. So we have f of x is equal to x squared cubic root of 2x minus 5. Now we have f of x naught equal to f of 2.5. In a function, we have 2.5 in bracket raised to power 2 cubic root of 2 open bracket 2.5 close bracket minus 5. When we solve this, we're going to obtain 0. All right, so the corresponding critical point is going to give us p of 2.5 comma 0 as the corresponding critical point. So we have for x naught 2.5, its corresponding critical point is equal to 0. Okay, I will say p of 2.5 comma 0 is the corresponding critical point. All right, yes. Now let's take the second question. You know, we have the function f of x is equal to x plus 5 in bracket squared cubic root of x minus 4. All right, yes. Now let's go. You know, we have f of x is equal to x plus 5 squared. Okay, now this cubic root of x minus 4 can be written as x minus 4 in bracket raised to power 1 all over 3. All right, yes. Here again, using product rule, we can differentiate this. So if we use the product rule to differentiate this, we are going to say that f prime of x is equal to 2 open bracket x plus 5 in bracket x minus 4 in bracket raised to power 1 all over 3 plus 1 all over 3 open bracket x minus 4 close bracket raised to power minus 2 all over 3 times x plus 5 in bracket raised to power 2. Okay, so let's simplify. We're going to have 2 open bracket x plus 5 close bracket open another bracket x minus 4 in bracket raised to power 1 all over 3 plus 1 all over 3 times 1 all over x minus 4 in bracket raised to power 2 all over 3 times x plus 5 in bracket raised to power 2. All right, yes. Let's simplify further. We're going to have 2 open bracket x plus 5 in bracket x minus 4 in bracket raised to power 1 all over 3 plus, now we're going to multiply 1 all over 3 times 1 all over x minus 4 raised to power 2 all over 3 times x plus 5 in bracket raised to power 2. So when we multiply, we are going to have x plus 5 in bracket raised to power 2 all over 3 open bracket x minus 4 in bracket raised to power 2 all over 3. All right, yes. Let's combine these together. You know, we have the LCM to be what? 3 open bracket x minus 4 in bracket raised to power 2 all over 3. All right, so when we combine this together, we are going to have 6 open bracket x plus 5 close the bracket, x minus 4 in bracket, plus x plus 5 in bracket raised to power 2 all over 3 open bracket x minus 4 close the bracket raised to power 2 all over 3. All right, yes. Now take a look at our numerator. Take a good look at it very well. Okay, so here, what do we have in common? We have two sides being separated by the addition sign. Okay, so when you look at it very closely, discover that we have x plus 5 in both sides. What we have in common there is x plus 5. So when we factor out x plus 5 from the left hand side, we are going to have 6 open bracket x minus 4 remaining, plus when you factor out x plus 5, here we have x plus 5 squared, so you factor out 1x plus 5, so 1x plus 5 will be remaining, so that when you use this x plus 5 to open this big bracket, it's going to give you the same term as above. All right, yes, all over we have 3 open bracket x minus 4 close the bracket raised to power 2 all over 3. All right, yes. Okay, now let's go in this bracket. Let's multiply and open this bracket. Okay, so when you multiply and open the bracket, we are going to have 6x minus 24. That is when you say 6x. That is when you say 6 multiplied by x is going to give us 6x, and then 6 multiplied by 4 is going to give us 24. All right, yes. Now we have plus x plus 5. Now we have all over 3 open bracket x minus 4 in bracket raised to power 2 all over 3 still in the bracket. We have 6x minus 24 plus x plus 5. So when you say 6x plus x, it's going to give us 7x. Then when you say minus 24 plus 5, it's going to give us minus 19. So in a numerator, we are having x plus 5 in bracket, 7x minus 19 in bracket, all over 3 open bracket x minus 4 in bracket raised to power 2 all over 3. So we have differentiated, and this is what we have. F prime of x is equal to x plus 5 in bracket 7x minus 19 in bracket all over 3 open bracket x minus 4 close bracket raised to power 2 all over 3. Okay, now let's go. We're going to replace x with x naught and equate it to 0. So when we do so, we're going to have f prime of x naught is equal to x naught plus 5 in bracket 7x naught minus 19 in bracket all over 3 open bracket x naught minus 4 close bracket raised to power 2 all over 3 all equal to 0. All right, yes. Now here we're going to equate the numerator and the denominator to 0. So for the numerator, we're going to have x naught plus 5 in bracket 7 x naught minus 19 in bracket equal to 0. So the first one will have x naught plus 5 is equal to 0. So x naught is equal to minus 5. The other time we have 7x naught minus 19 is equal to 0. So we have 7x naught is equal to 19. Divide both sides by 7. So x naught is equal to 19 all over 7. In decimal form, x naught is equal to 2.71. For the denominator, we have 3 open bracket x naught minus 4 close the bracket raised to power 2 all over 3 is equal to 0. So 3 is not equal to 0. Okay, so the term in the bracket we have x naught minus 4 equal to 0. Here we're having 2 all over 3. So when you remove the 2 all over 3, the other side is having 0. Whatsoever it is, it's going to give us 0 also. Okay, so we don't mind whatsoever that is our power. All right, since the term in the right hand side is equal to 0, so whatsoever you do, it will give you 0. All right, so let's go. We have the term in the bracket x naught minus 4 equal to 0. So x naught is equal to what? 4. So here we have solved and we obtain the following as the critical numbers. X naught is equal to minus 5, X naught is equal to 2.71, and X naught is equal to 4. These are the critical numbers. Now let's go and solve for their corresponding critical points. Now for X naught equal to minus 5, so we have a function f of x is equal to x plus 5 raised to power 2 cubic root of x minus 4. All right, yes. So we're going to plug in minus 5 in this function. So we're going to say f of x naught is equal to f of minus 5 equal to, in the function anyway we'll see x, we replace it with minus 5. Let's see what we're going to have. We're going to say minus 5 plus 5 squared cubic root of minus 5 minus 4. So when we simplify this, it's going to give us 0. So here we're going to say that p of minus 5 comma 0 is the corresponding critical point for the critical number x naught equal to minus 5. Let's go further. For x naught equal to 2.71. Now in our function we're going to plug in 2.71 and see what we're going to have. Now let's go. We have f of x naught is equal to f of 2.71 is equal to, in a function now, open bracket 2.71 plus 5 squared cubic root of 2.71 minus 4. When we simplify this, we're going to have minus 64.71. So p of 2.71 comma minus 64.71 is the corresponding critical point for the critical number x naught equal to 2.71. All right, lastly, the corresponding critical point for the critical number x naught equal to 4. You get it? So in a function we're going to plug in 4 to see what we're going to obtain. So f of x naught is equal to f of 4 equal to 4 plus 5 in bracket squared cubic root of 4 minus 4. When you simplify this, it's going to give us 0. So p of 4 comma 0 is the corresponding critical point for the critical number x naught equal to 4. All right, yes. Thank you very much for watching. Please, I want you to watch this tutorial step by step. Watch it very attentively. Okay, all right. Thank you for watching. See you next time. Let's take more examples for better understanding. All right, okay, let's go.